Hello, and welcome to our presentation of the assembly of a shock absorber created using SolidWorks. This is our final project presentation of DFT-170 Engineering Graphics in the spring 2023 semester, taught by instructor Dr. Hans Chapman and created by Justin Dallas, Justin Pinilla, and myself, Daniel Hart. These are a few of our reference images we used as a guide to begin our modeling of a shock absorber. We found this example in our Vital Source textbook and used these examples as a rough estimate of the size, dimensions, and individual parts that would be required to design and create this assembly. Noting that there were no specific dimensions given, we relied on previous learning experience, research, and intuition to decide what size and material each part should look like and be made from to maximize efficiency. As stated previously, we did not receive any of our dimensions from the reference images in the book, so through research of shock absorbers, drew up these hand sketches to determine the correct proportions of each part in relation to one another. This prior planning was a very important step in the brainstorming process, and through trial and error, we found the best size correlation between each part.
These are parts 1 and 2 of 6 total components used in the shock absorber. The bolt was made from extruded boss base of a hexagon and circle shape, while the frame used fillets and extrusions. These are parts 3 and 4. The nut and pin were both made from extrusions. In our application, the nut is placed at the end of the bolt, while the pin is pushed through a small hole at the top of the nut. The pin would also go through the bolt, locking the nut in place. These are parts 5 and 6. The load bearer was made from two extruded rectangles placed on top of each other, while fillets were used in two corners to give the bottom of the load bearer a rounded finish. The bushings were made from two extruded circles. Both of these parts used extruded cuts. In our application, the load bearer would be fixed in place and the two bushings would be inserted at both ends of the load bearer. The bushings are to prevent wear to the load bearer and bolt.
This document shows the front, top, right, and isometric views of our shock absorber. Detailed views were left out as they could not provide any extra information to the document that was not already supplied by the normal views. This is a vertical load simulation on the spring. The spring is made of 304 stainless steel. The bottom of the base is fixed while the load of 100 newtons was applied to the top of the shock absorber. As you can see, the shock absorber deformed from this amount of force pressing down on the top of it. We believe the reason it could not withstand more force is because of the design of the spring inside the shock absorber. This video shows an animation of the spring within the shock absorber moving up and down. This movement simulates what the shock would experience in any real-world application.
To end with our concluding remarks, our members as a whole learned how important it was to function as a team during the making of this assembly. Continuing to assign each other different tasks through the duration of this process helped us to maximize our time management skills and allowed us to work as effectively as we could. Brainstorming was the most important step in this process to be as efficient as possible, and this taught us how integral it was to plan first and then think ahead to the bigger picture after. The technical aspect of the assembly was also very tricky at times, and during the construction of the spring, we found it necessary to build the part of our absorber inside the assembly itself. This was because the spring had to be created in relation to the mates we used between the load bearer and the base, and only through defining smart dimensions inside the assembly were we able to make the spring move in the correct fastened motion. We hope and feel this assembly is a good representation of a design that can be used in multiple real-life applications, and have all gained a better understanding of how shock absorbers function and the most important aspects that go into creating one. We hope you've enjoyed this presentation, and thank you for listening.